Students, in lesson 11.4, we're going to be working on problem solving and properties of two-dimensional figures. Our essential question for this lesson is, how can you use the strategy acted out to approximate whether the sides of a figure are congruent? So let's start with our unlock the problem real world. Lori has a quadrilateral with vertices A, B, C, and D. The quadrilateral has 4 right angles. She wants to know that the quadrilateral ABC is a square, but she does not have a ruler to measure the lengths of the sides. How can she show that the quadrilateral has 4 congruent sides and is a square? Use the graphic organizer below to help you solve the problem. So on the side we see the quadrilateral ABCD. So what we're going to do is we read the problem and we need to know, what do I need to find? What we're going to say, I need to determine whether the quadrilateral has 4 congruent sides and is a square. Next, what information do I need to use? The quadrilateral has 4 right angles to be a square. It must also have 4 congruent sides. Then, how will I use the information? I can trace the figure, cut it out, and then fold to match each pair of sides to show that the sides A, B, B, C, C, D, and A, D are congruent. So what we're going to do, boys and girls, is we are going to solve the problem. First, I traced the quadrilateral and cut it out. Next, I used acted out by folding to match each pair of sides. I fold the quadrilateral to make side AB to match side CD. So we made a fold down the center of the quadrilateral. Next, I fold the quadrilateral to match the side AD to the side BC. Finally, I fold the quadrilateral diagonally to match the AD side to the AB side and the CD side to the BC side. It says, what else do I need to solve the problem? What we would say then, boys and girls, is I need to show that sides BC and AB are congruent and that sides CD and AD are congruent by folding on the diagonal. So the quadrilateral ABCD is in fact a square because it meets all of these recommendations for classifying a square. Next, we're going to try another problem. Our next problem here is about Terence. So let's read it and get going. Terence has drawn the triangle with the vertices E, F, G. The triangle has 3 congruent angles, so we know that these angles are congruent, which means that they are the same. He wants to show that triangle EFG has 3 congruent sides, but he does not have a ruler to measure the lengths of the sides. How can he show that the triangle has 3 congruent sides? So we're going to go through our next problem-solving strategy steps as well. 1. First we read the problem and it says, what do I need to find? I need to determine whether sides EF, comma, FG and GE have the same length. And we need to do that because we don't have a ruler and we can't measure the actual triangle. Next, what information do I need to use? We would say the figure is a triangle with 3 congruent angles. Next, how will I use the information? I will trace the figure, cut it out, and then act out to match all the sides. Comma, to see if they are congruent. So what we're going to do is we are going to now solve the problem. We're going to record our work by drawing your model after each fold. Label each drawing with the sides that you find are congruent. So we're going to do this together in class, but we're going to first fold the triangle and this little dash line is going to represent our fold. And then underneath it, we're going to have our other side of our triangle. So we have E, F, and G, which is the one that's underneath E. So we see that E, F is congruent to FG. Next, what we're going to do is we're going to show our other fold. So our next fold would be by the diagonal line, and then underneath it we have the fold that is hidden by the original fold. So we have F, and then we have G. And when we fold that, we can see that E, F is also congruent to E, G. So by our drawings, boys and girls, we see that the triangle, in fact, is congruent and that there are 3 sides that are all congruent, because EF is congruent to FG and EF is congruent to EG. So we know that even without the ruler, that our triangle has 3 congruent sides. Next, it says, how can you use reasoning to show that all 3 sides of the triangle are congruent using just 2 folds? So what we can say, boys and girls, is since 2 pairs of sides are congruent, the third pair are congruent. Since they have related sides. Since EF is congruent to to FG, and EF is congruent to EG, sides FG and EG are congruent. So throughout this lesson, what we're going to be doing is we're going to be analyzing the properties of two-dimensional figures, which means that we're going to be analyzing its sides and its angles. So it's really important that you take the time to trace these figures out and test these through all the different kind of two-dimensional figures that we've related in this chapter: polygons, triangles, and quadrilaterals.